Waves are formed by the frictional drag of wind across the water surface. This is a process of transferring energy from wind to water. Water particles are moved from their position by the wind and then returned to the original position by gravity, which is a restoring force. These waves are called owing to retardation of the tidal wave in the ocean by frictional force, as the Earth revolves daily around its axis and as the tide tends to follow the direction of the Moon. The highest tide for each location is not coincident with conjunction and opposition but occurs at some constant time after new and full moon. This interval, which may amount to as much as 2.5 days, is known as a hypothetical wave having a wave height and period equal respectively to average values of the wave height and period of the largest a third of all waves in the train as counted in the order of greater wave height. A maximum wave height and wave period of the maximum wave height and wave train. Generally, the width of the harbor entrance should be a dock which is parallel to the shore, which can be used for docking on one side only. A dock which projects into the water, which may be used on docking for both sides. A dock which is similar to a wharf and often referred to as such, is back up by ground as it derives its name from the very nature or supporting ground in the back of it. Harbors can be broadly classified as I. Natural harbors, 2. Semi-natural harbors, 3. Artificial harbors, 4. Commercial harbors. The harbor entrance should, if possible, be located on the of the harbor. For harbor basins, the width required to permit a ship to swing freely into a berth is for berths at 45 degrees. For harbor basins, the width required to permit a ship to swing freely into a berth is for berths at 90 degrees. When more than one ship has to be accommodated along the berth, a clearance length of should be provided between the adjacent ships. The maximum current velocity through the harbor entrance should not exceed For a single berth pier, the clear water area between two piers should be to allow for tugboat assistance. The pressure against a vertical wall due to waves is called the ratio of the wavelength to its height for ocean waves is between a very long-standing wave on a large but limited body of water, generally occurring when a storm dies down after producing a white tide, is called the stopping distance of a ship will depend on factors such as ship speed, the displacement and shape of the hull, and horsepower ratio. The stopping distance of a loaded ship. Waves generated by wind that are acting on the sea surface bordering on the port site. An instrument used to measure the intensity of wind. The safety distance between two moored tankers or moored tanker and a passing ship will depend upon the overall layout of the harbor, the number of tugboats assisting in the berthing or unberthing operation, the environmental conditions and the population in the area. The safety distance between a moored oil tanker and a passing ship shall be Waves continue to grow after they reach a velocity equal to, but at a decreasing rate, energy losses from friction, transfer of energy into currents, and the development of white caps means the wave will not grow until the wave speed reaches the wind speed. The wind speed is 146 kilometers per hour. An open water of navigable depth is called. The size of water area for anchorages will therefore primarily depend on the number, type, and size of ships, which require protection, and the type of mooring system available. The water depth at an anchoring area should preferably not exceed approximately due to the length of the anchor chain of the ship. The bottom condition must not be too hard, otherwise the anchor will be dragged along the bottom and not dig into the sea bottom. Waves created by large, sudden impacts, such as earthquakes, volcanoes, or landslides that ends up in the ocean. Waves generated by storms which occur outside area of observation. A change in the dissection of travel of the wave with change in depth of water which distributes wave energy along the seashore unevenly is called. Waves in which the ratio of water depth to the wavelength is equal to or less than 0.4. Waves in which the ratio of water depth to the wavelength is greater than 0.5. Waves in which the ratio of water to depth to the wavelength is less than 0.5 but greater than 0.4. Waves of this type have very long periods, typically from 30 seconds up to the tidal period of 12 hours, 25 minutes, and are mostly found in enclosed or semi-enclosed basins such as artificial port basins or bays. the arithmetical mean value of the highest 1/3 of the waves for a stated interval. The distance that the wind blows over sea in generating the waves is known as the difference in height between the mean higher high water and the mean lower water is called the ratio of the wave height to its wavelength is called the highest tides, which occur at intervals of half a lunar month, is called waves with an extremely long period that mainly occur when there is a sudden large-scale seafloor movements associated severe, shallow focus earthquakes. The falling tide is known as wind-generated waves, which are created in the deep ocean at some distance from the port site, and the wind that created them may be too distant to be felt in the port or may have stopped blowing or changed its direction by the time the wave reached the port. When the lines connecting the Earth with the Sun and Moon form a right angle, that is, the Moon is in her quarters, then the actions of the Moon and Sun are subtractive, and the lowest tides of the month occurs. This is called waves formed by moving ship or boats are called wind-generated waves, but are created in the deep ocean at some distance from the port site, and the wind that created them may be too distant to be felt in the port and may have changed its direction by the time the waves reach the port. The period during which the current is negligible while it is changing directions is called. It is the period during which the current is less than a tenth of a knot or less than 0.169 fs. Waves continue to grow after they reach a velocity equal to of the wind speed, but at a decreasing rate. Energy losses from friction, transfer of energy into currents, and the development of white caps means the wave will not grow until the wave speed reaches the wind speed.